Hello ladies and gentle ladies, and welcome back to another Minecraft modding tutorial for Minecraft 1.21 with Fabric. And in this tutorial we're going to be talking about screen handlers. So a screen handler is effectively going to be an intermediary between our block entity and our screen. So if you're used to official mappings, these are referred to as menus, or if you're used to the kind of old mapping system of MCP, these are containers. So they're effectively just a middleman between your block entity or an item or an entity and a screen. And this allows you to have things such as item slots or also to sync some data. Now we're not going to be talking about either of those two things in this tutorial. We're just going to have this set up so that we can create a screen that is linked to our block entity, and then we'll move on from there in the future tutorials. So to get started with this, we're going to come into our block entity class. Now I'm just going to use our generator for this, our energy generator, and I'm just basically going to display an energy bar in the screen. That's all I want to do, and it will also show the player inventory as well. So we will add some slots, but we're not going to be adding slots for our own inventory because we'll be doing that in the next tutorial. So all we need to do is add another interface to our implements here, and that will be the ExtendedScreenHandlerFactory. Now this is generic, so we do need to go ahead and pass in a payload that this will take, and this payload will be used on initial syncing. So you can have an initial piece of data that you are transferring between the two that the screen handler will receive when it is constructed, and the payload that we want to send is simply just going to be a block position, since we want to be able to tell the screen handler that when it's opened, it will grab our block entity from that position. If you were doing, say, an item that would open your screen handler, then you might pass in the item stack instead. If you're doing an entity, then you might pass in probably the block pods as well, but possibly also an entity type maybe, or maybe an entity ID, depending on the best way you wanted to do that. Probably an entity ID would be the best way to do that, but we're not going to be doing any of those things. We're just going to be passing in a block pos, since this is going to basically be a constant position. It's not going to change. So we are going to do a block pos payload, and this is not a thing that exists, so we will have to go ahead and create that class. So I'm going to create a new package inside of our main package, and I'm going to call this network, and I'm just going to minimize some things here, and inside of a network we're going to create a new class, and this is going to be a record, and this is going to be a block pos payload. Now simply all this record will have is a block pos, since that's the data that we want to send across, so that will be the block pos, and this class needs to just implement custom payload. Then we need to just implement the method that it wants, which is the getID method. And then we need to just create the ID that we can return in there. Now to create an ID, all we need to do is create a public static final. This will be called an ID, so not an identifier. This is an ID. This is different. It's kind of like an identifier, but it's unique to custom payload, so it's a little more specific in what it actually is. If you go into it, you can see it effectively is just an identifier and just a record of one, but basically it will be generic, so it's specific to the payload you're creating it on. So this will be an ID of type basically this, so a block pos payload, and we can just call this the ID, and I'm going to set that to a new ID, and this just needs to take in an identifier. So we can luckily use the method from our main class, so we're going to go tutorial mod .id, and then just the name of the payload. So this is a block pos payload, so I'm just going to call this block_pos, and same with all other identifiers. This has to be lowercase, it has to have no spaces, no special characters, and all those kind of things. So we're just going to call it block pos, since that's what it is. It's a block pos payload. Then we can just go ahead and return the ID. What we also need to go ahead and do is create a codec, and we're probably not going to use this codec, but we do need to create it anyways. So we're going to create a public static final packet codec, and this will be of type registry byte buff and the block pos payload. And we're just going to call this the packet codec. And that'll be equal to packet codec dot tuple, and this will take in block pos dot packet codec. It will then take in block pos payload colon pos, and then block pos payload colon new. So effectively what this is a codec is something that allows you to serialize and deserialize to a bunch of different formats. So you may want to have a codec and you may want to use that to encode to JSON or encode to MBT, or in this case encode to a byte buff, which is for packets. And effectively we are encoding that to a registry byte buff, so that means it has access to the registries. And this is specifically a packet codec, as I said, so that means that this can be used to encode to the packets. I wouldn't worry too much about codecs, we will get into them more in the future, but effectively what we're saying is that this is just a tuple codec, so it will use the packet codec here from the block pod, so that's an existing codec, and then it will use this as the kind of like a getter, and this is like the kind of like a setter, I suppose. So you're creating a new payload, passing in the position there, and then you're just getting the position from the payload here. So that's effectively how this works. The next thing we need to do is obviously import that inside of our block entity class, and then we need to implement the three methods that it wants, which is get screen opening data, get display name, and create menu. So get opening screen data will be the method that will construct our payload that we need to pass through to the screen handler. So this is going to be nice and simple. All we need to do is say a new block pos payload this.pos. Now it is worth noting that maybe you wanted to pass some other data into the screen handler, and you would do that through this way as well. So you'd create a new payload, and you'd probably want something not just a block pos payload. So you might want to pass in some extra data, maybe an enum and something else. So basically inside of your payload you would have it, so instead of it just being a block pos, you might also have something like a battery level, which is like an enum, and then you would pass that in there, and then you would also need to adjust your packet codec here. So the way that tuples work is that we could then have a new line which would use this like that. So you would have your new at the very end, and then you would have your packet codec for the battery level, and then you would have your getter for the battery level here. We're not going to worry about that too much, as I said, because we're going to kind of cover that in the future a little more in depth, but for now don't worry about it too much. We're just going to be using a block pos payload. Then the display name, this is effectively just the name of your screen, and this is the name that would be displayed at the kind of title of your screen. So in here we need to return a text, and as usual we need to just create a constant for this, so we don't want to reconstruct that every single time that we open our screen. So we just like to make this a constant, and I'm going to set this to text.translatable, and this will just be container dot and then plus our mod ID. So our mod ID is tutorial mod, and then basically the name of your screen. So ours is just going to be example energy generator, like that. And then all we need to do is go ahead and return our title in here. And before I forget, I am just going to add that to our lang as well. So I'm just going to say add text. I'm going to pass in the translation builder, then I'm going to pass in the title, so that is going to be example energy generator block entity dot title, and then I'm just going to basically pass in this exact string here, so example energy generator. Nice and simple like that. Then we need the create menu, and this is going to be nice and simple. So all we need to do is say a new, and then the name of whatever your screen handler will be called. Generally, you should just keep it the same kind of convention. So for me, this will just be an example energy generator screen handler, which is obviously quite a long name, but that's just kind of consistency, and we're going to keep things roughly the same. This just needs 3 parameters that we're going to put in here. That needs to be the sync ID, which we're getting from this method here. Then it needs to be the player inventory, which we're also getting from this method here. And then we also need to pass in this, which is the block entity. Now do note that this create menu method, this one specifically, constructing our screen handler, will actually go ahead and be called server side. So this is called on the server side, and you'll see why that's important very soon. Now obviously you could pass in any other data in here as well that you needed to. So basically your payload, if we find our payload here, this screen opening data, this is also called on the server, as you can see, because it has a server player entity. However, when this is actually given to the client, it will call a different constructor, and that constructor will take in the sync ID, it will take in a player inventory, and it will take in that payload. So anything that you pass into this constructor also needs to be able to be grabbed from whatever payload you're passing in. And you'll see what I mean by this in a second. So let's go ahead and actually create this screen handler class. So let's create a new package inside of our main package, and I'm just going to call this screen handler, and then I'm going to create a new class, which is our screen handler class. This class is simply just going to extend screen handler like that, and we're going to need to implement the 2 methods. And then we're just going to add the constructor as well. Now in the constructor, we need to remove our ScreenHandlerType parameter, and we're going to actually need to go ahead and register this ScreenHandlerType in a minute. But for now, let's do the constructor. So we're going to have a player inventory, which will be the player inventory. And then if you remember from our block entity here, we passed in this, which means that this needs to be a example energy generator block entity. And if we go back into our block entity class, we can now go ahead and import our screen handler, and that just gets rid of any errors that we have there. So we can now go ahead and close that class completely. Now, before we continue, I am just going to create a field for our block entity. So this can be accessed, for example, from our screen, which is just a little bit handy. So I'm going to create a private final example energy generator block entity, and I'm just going to set that in the constructor to the parameter that we're passing in here. So the important thing to note is that this is the server constructor. So this will be called on the server side. Now we also are going to need a constructor that's called on the client side, since the way that screen handlers work is that there is actually 2 separate instances of each screen handler when it's created. So you would have a instance of the screen handler that is on the server, and that's called from your block entity. And then you also have a screen handler that's created on the client as well, and the client constructor needs to actually call your server constructor. So this constructor isn't actually, it's interesting because this constructor isn't technically server-sided. However, this is the constructor that's called from the server, if you think about it like that. So I'll create the client constructor and you'll kind of see what I mean. So if we create a public example energy generator screen handler, we are going to need the sync ID, so int sync ID. We're going to need the player inventory, so nothing unusual there. And then we are actually going to need our payload. So we're going to pass in the block pos payload. Now what this constructor will do is it will actually call this constructor here. So we can pass in this, the sync ID, the player inventory, and then we also need the block entity here, which we can luckily get from the player inventory and from our payload. So we can use the player inventory.player, and we can get the world, and then we can get the block entity at the payload.position, And then all we have to do is make sure we cast that to our block entity class. So as you can see, how this works is this constructor here, this will be called on the client when a packet is sent to open the screen handler. So the way that it works is on the server side, we will go ahead and say that we want to open a specific screen. And the way we do this is we say, in fact, let's go ahead and actually do that now, and then you'll see what I mean. So if we go into our block class here, and on use, instead of sending this message, which we don't want to do, we are going to say player.open handled screen. And then we're just going to pass in our block entity like that. That's all we need to do. So what this does is it tells the player that it needs to open a specific screen handler, and the screen handler that it's passing in is the one from our block entity here. So you see this implements the ExtendedScreenHandlerFactory, which tells it how to construct the menu here, as you can see. So this is the constructor that this will call when we go ahead and open our handled screen. So this is going to be server side, because as you can see, we are using this if we are not on the client side. So what that will then do is that will go ahead and construct the server screen handler, and then it will go ahead and send a packet. So what a packet is just a small piece of information that it's going to send over the network to the client side. When the client receives this packet, it will also receive this payload inside of that packet. And this payload, as you can see, will take in the block position. So what this will then do is inside of our screen handler, it will call this constructor on the client. And this constructor, as you can see, takes in the payload. Then using that payload, what we're effectively doing is we're grabbing our block entity out of that payload using the position. And what that then does is that calls our constructor here that takes in the block entity. So we're able to grab that block entity and use it the way that we want to be able to use it later on. So that may be used, for example, for creating these slots. You might need your block entity to get the inventory and then create the slots. Or you might have custom data that you need to have synced. So luckily, this is pretty much all we need here. We do, however, need to create a context, because we're going to need to fill out these two methods right here, which is quick move and canUse. So this quick move method here is called when you shift click an item in the inventory, and it will quick move basically that item from maybe your inventory to the screen handler's inventory. So we need to be able to actually do that. Now we don't actually have any slots in here, so I am just going to return item stack empty. However, that's not really going to be ideal, because that also means we're not going to be able to quick move within the player's inventory either. So ideally we would have some actual logic to be able to handle that. I'm not going to do that in this tutorial, because that will make this tutorial quite long, and this quick move method can get quite complex quite easily. So I'll talk about that more a little later when we actually do the items inventory tutorial for the block entity. The next method you can see here is the canUse method, and this defines whether or not we can actually open the screen given the specific instance of the player. So you might have certain restrictions that define that a certain player cannot open a certain screen for some reason. Maybe that screen has been locked by your block entity. So you might have something in your block entity that says only players with some certain condition can open this screen. Maybe it's been locked to a specific team or something like that. You might have something like that. But the most basic thing that you're probably wanting to do in here is just a basic distance check and also a block check. So you want a distance check to check that you're not more than the normal distance away from it. And then you also want a block check to check that this menu is actually being opened from your block and not some random source opening your menu, as obviously that could cause you problems with getting the block entity. So luckily, Vanilla actually has a method we can use, And this is also called canUse. However, this one is a static method, and you'll see this needs a screen handler context. Now, this is not null, so you do actually have to pass this in. However, I am going to give it null, as silly as that sounds, because we're going to pass in the other two parameters first, and then we'll talk about this screen handler context in a second. So I'm going to pass in null just to kind of get past that parameter. Then we need to pass in the player, which we can get from this parameter here, and then we need to pass in the block that this is going to be valid for. So the block that I want it to be valid for is going to be block init.example energy generator block. Now, if you have multiple blocks that you need this to be valid for, then you do need to go ahead and actually chain this canUse method. So you might have, for example, that, and then you might have an or statement and then say canUse on a different block as well. So for example, the ticking one, just as an example, basically saying that it's then valid for both of those blocks. Now, what I actually have in one of my mods is I just have a method that I can pass in a var args of block, and that basically means it will loop through all of those blocks and then automatically call this canUse method. That's just handy if you have multiple blocks it's valid for, but obviously we don't want that, so I'm not going to worry about it. But you can obviously create that method if you feel like that's necessary for you. And let's go ahead and fix this context since we can't pass in null here. So we need to create a screen handler context, and I'm going to create this as a field, so a private final screen handler context, and I'm just going to call this context. Then inside of our server constructor, or effectively this is kind of the main constructor, but this is also called from the server. So we can also say, for example, called from server, or we could say something like directly called from server. And then this constructor is the client constructor, because this is only going to be ever called from the client. I think that makes more sense to put it like that. So then let's create the context. So we're going to say this dot context, and I'm going to set this equal to a screen handler context dot create, and we need the world here, so we can get the world from either our block entity or from the player inventory. It's safer just to get it from the block entity, so I'm going to do that. I'm going to say this dot block entity dot get world and this dot block entity dot get pos, which will go ahead and create that context that we can then use inside of the canUse method. The second to final thing that we need to go ahead and do is create our inventory slots as well for the player inventory. So we're not going to be creating any for our block entity. However, we do still want to have the player inventory visible. So I'm actually going to go ahead and create two methods that I will use for this, but I'm going to just call them first. So I'm going to add player. So the first method is going to be add player inventory, and this will just add the 9x3 kind of player main inventory, and this will pass in the player inventory. Then I'm also going to create add player hotbar, and this is just going to add the 9 slots hotbar like that. Then we're going to create these methods. So let's start with the player hotbar actually, because I think the hotbar is the easiest to go through first. So I'm going to create a private void add player hotbar. We'll take in the player inventory. I'm just going to call this the player inv, and what we're going to do is we're going to create a for loop. So we're going to say for I am going to call column so that we're more descriptive in what this is. That will start at 0, and then it will be less than 9, since there are 9 slots and the index always will start at 0. Then we're just going to call add slot, and we're going to pass in a new slot. This first needs to take in the player inventory, so I'm going to say player inv. Then it needs the index of this slot. Now the index is just going to be this column here, so we're going to say column. Then it needs the x coordinate. So in order to determine the x coordinate, we are actually going to obviously need a texture that we're going to create. So I don't actually have a texture yet, so I'm going to quickly go ahead and get a texture, and then I'll be back with you so that we can calculate this. Okay, so this is the texture that I have created. It's literally just basic texture that you could have for a player inventory GUI. So I've just got the player inventory here, and there are no slots for our block entity inventory. However, in the future we will probably change that and add a slot in there as well. But for now we've just got a 3x9 and then a 1x9. So what we're going to do is we're doing the hotbar, right? So what we're going to need is the top left position of the first slot. So as you can see, this is 8 and 142. So all we're going to say is that the X position of the slot will be 8 because we're starting at the X of 8 plus the column, so whatever the column is, and we're going to multiply that column by 18. Now, why 18? You may think slots are 16 pixels, so why are we multiplying by 18? Now, the reason we're multiplying by 18 is because, yes, a slot is 16 pixels. As you can see, it's 16 by 1. However, we also need to do the buffer here of 2 pixels, right? Because each slot has a border of 1. So that means that to get to the next position, we actually have to go another 2 across, which means that this is a width of 18, not 16. So we need to times the column by 18. And let's just put that in brackets so that it's pretty clear that we're doing that first, just in case it gets too confusing. Then we need the Y position, which once again is going to be this top left kind of, or top position here, which as you can see is 142. So let's go ahead and put that in. So the Y position is 142, and that doesn't change, so we don't need to use the column for that or anything like that. Next, let's do the player inventory. Now, this is going to be pretty much identical. However, we do need to do a calculation for the Y position for this one instead of just keeping it a constant. So we're going to do player inventory instead. And this is going to be effectively the same. However, we're going to surround this for loop in another for loop. And this will be for the row. So row is 0. Row is less than 3 because there are 3 rows, as you can see. 1, 2, 3. Let's put this in there. So this is effectively going to be the exact same. However, the index is also going to be different because we need to start from 9 as the first index. So how do we calculate that? Well, the easiest way is to start with 9. So we're going to say 9 plus, and then we are going to do the column plus the row times 9. So what we're effectively saying here is, let's say that we are on the first slot. So let's say we are here. Both of those loops will be at 0, 0 because we're on the first run of each loop. So this is 0, this is 0 because it hasn't incremented yet. So the index, so the column and the row are going to be 0. So that's 0. So 0 times 9 is 0. So the index is 9. Let's then say that the column will be 1 because this loop will run first. So the column will now be 1. The row is still 0. So effectively, the index is going to be column plus row, right? So the column is 0. The column is 1. The row is 0. However, it will do row times 9 first, right? So this calculation happens first because obviously that's how, math works. So the row will be multiplied by 9, meaning that it is still 0. So 0 plus 1 plus 9. So that means that the index is now 10. Let's now go down a row. So we'll go to row of 1 and a column of 0. So where is that? So that is going to be this slot right here. So the row is 1, the column is 0. So we do 1 times 9 plus 0 plus 9. So we're now at an index of 18. And that is going to be correct because this is going to be 9 slots across, right? So this is 9 to 17. Then this here is going to be number 18. So that makes that correct. And you see how that then works for each of the rest of the slots as well. Then we need to do the X position for the slot. So for that, we are going to say effectively the exact same as what we did for the hotbar. So that's just going to be 8 plus the column times 18. It's going to be exactly the same. Then we need to do the Y position, which once again is going to be exactly the same calculation here, but the only difference is obviously this little offset here. The starting position is going to be different. So the starting position, if we have a look here, so the start Y position is 84. So what we need to do is we need to say 84 plus row times 18, and we're using the row instead of the column as well because we're doing the Y positions. And that is it. That will go ahead and add the whole player inventory there. There is one other thing I am going to go ahead and do, and that is to actually create a getter to get our block entity. So a very basic getter here. We're going to say public energy generator block entity, get block entity, and I'm just going to return this block entity. I'm also going to create some methods to actually get our energy from the block entity as well. So I'm not going to go ahead and write these out manually. I'm just going to copy them across. But as you can see, what this effectively does, so we have a method to get the energy, which will get it as a long from our energy storage. Then we have a method to get the max energy, and then we have a method that will just calculate the percentage as a float. So between 1 and 0, it clamps the energy over the max energy to 0 and 1. If either are 0, we just want to return 0 because otherwise this could give us some weird values. So we don't want to have to deal with that. But that should go ahead and work. And we're going to use that in our screen very, very shortly. However, before that, you can see that we do have an error in here. And that is that we don't have a type. So we are going to need to use a ScreenHandlerType init.example_energy_generator, and obviously we need to go ahead and create that. So inside of our init package, we'll create a new class, and this is just going to be a very normal init class. So we're going to have a public static void init. Call it init or load? I better call it load, didn't I? So that will be a public static void load, which just loads that class. And we're going to quickly go into our main class and make sure we call that. So ScreenHandlerType init.load. And then we need to create a register method. So we're going to go a public static t extends ScreenHandler. Now this method is actually not going to be quite like normal, and we're actually going to need to make it even more generic than just a t extends ScreenHandler. We also need to have a d extends custom payload, and that is because we need to define our codec that will actually be used for the payload that we pass in to our ScreenHandler. Now you don't have to call this D, of course. You could call this P. In fact, let's call it P, sure. But it doesn't really matter because obviously T doesn't exactly make sense. But this will effectively then return an extended ScreenHandler type of T, and I'm just going to do D. I think D makes more sense. I don't know why, it just makes more sense to me. Also, probably the fact that this takes in T and D instead of T and P. We can obviously call this register just like normal, and that will just take in a string name because that's how we always do things. But there are some other parameters that we obviously need to take in. So first we need to actually take in the factory, which will be an extended ScreenHandler type dot extended factory, which will take in T and D, which is the factory. And then we need the packet codec. So we're going to take in a packet codec. The first type will be $extends registry byte buff. And the second type will be of type D, which is obviously the packet codec. So this is quite a long method here, and it has quite a few parameters. So let's see if we can find a way to just make this a little easier to read. So these are going to be our parameters. Okay, I think that's okay. That's also kind of weird, but it works and it's not going to be too janky. So in here we are going to basically do the normal thing, but it's also going to be slightly different. So we're going to have return registry from net.minecraft.registry.register registries.ScreenHandler. Then we're going to need to pass in the ID as usual. So tutorialmod.id, which takes in the name. And then we need to pass it a new extended ScreenHandler type, which takes in the factory and the codec. And actually, I've made a little bit of a typo here. So this needs to be $super registry byte buff, not extends registry byte buff. And that just fixes our little error that we had there. Then we just need to make sure we actually register our ScreenHandler type. So we're going to create a public static final ScreenHandler type of type example energy ScreenHandler. And that will just be called, obviously, example energy generator, which will then be equal to register. Then we're going to give it a name, so example energy generator. Then we're going to give it the constructor, which will be example energy generator ScreenHandler : new. and then it needs to take in the packet codec from our payload, which will be the block pos payload dot packet codec. And you see that this constructor here that it's using for the : new is actually the one that takes in our payload. So that's the one that how it knows what constructor the client will be using. Okay, so now we can go ahead and actually close all of these classes, and we can go into our client source set and in Java, and we can create a new package for screen. And inside of here, we're going to create a new class, which will be called example energy generator screen. Now this class is going to extend handled screen, which will take in the type of our menu, which will be the example energy generator screen handler. Then we need to go ahead and implement the method, which is drawBackground, and we can go ahead and create the super constructor as well. The first thing we're going to do is actually create an identifier, which will be used to locate our texture. So I'm going to create a private static final identifier. I'm going to call that texture, and that will be equal to tutorialmod.id, which will take in textures / GUI, and then I like to put my container or handled screen textures inside of container, and then I'm just going to call it what it is. So example energy generator, and you need to make sure that is a .png as well. Now the screen is actually quite complex, and there is a bunch of stuff you can do in here, so I will briefly try and show you some things you can do. So you can override the init method, which is called basically when your screen is constructed or when the widget should be rebuilt. So also, for example, if the screen is resized, then init will be called. In here, you can basically do a bunch of things. So for example, you can set this .titleX. And what I like to do is I like to actually center the title. Now, I know that's not generally common practice. However, you can do that using this. So it uses the background width, and then it negates the width of the title using the text renderer, and it basically divides that by 2. So that would center the title X position. And you can imagine you can also do that with the title Y as well. And you can also do the player inventory title X and title Y too. Also, inside of the init method, this is where you add widgets such as buttons or scroll bars or all of those kind of things. You can add them in here as well. And the way you do that is you call add drawable child, and then you can pass in basically the widgets. So the way you create a widget is generally using, for example, button widget. And you'll see there is a builder on this that you can pass in the message. I'm not going to worry about that too much, but you can also have, for example, a press action. So this is when the button is pressed, which you may want to then send a packet to the block entity to change some data. Then you can call other methods on here. So you can say the dimensions, you can give it a tooltip, you can say the narration supplier, or you can directly give it positions, widths, heights, and all those kind of things as well. And then you can obviously build it, and then that will add a button to your screen, which is super handy. But I'm not going to go through all of that because that's kind of a little bit out of scope. And instead, we are just going to draw our background. So we are going to come into draw background here, and we're going to say context draw texture. We're going to pass in our texture. Then we are going to say this.x, this.y, 0, 0, this.background width, and this.background height. Now, I should note that if your texture is not 176 by 166, which is kind of the default values for this background width and background height, then you will need to change that in your constructor. And what I mean by that is if you come into the texture here, you can see the actual texture itself is 256 by 256 because it has to be 256 by 256. If it's not, then you actually need to pass those as separate parameters here afterwards. So if you had, for example, 512 by 512, then you would need to be using it like this. But for 256, we can just actually not supply those because that's the defaults. But if your texture is not, so if we grab the size of our texture here, you can see down here it says 176 by 166. So that is actually what this background width and background height are set to. They are set to 176 by 166. Now, if you wanted to draw something bigger or smaller, then you would need to say in your constructor that the background width is, for example, 170, maybe the background height could be 200. I don't know. Obviously, you would check your texture and you would see how much do you want to actually draw. Also, likewise, if for whatever weird reason you didn't want to start at the edge, maybe, for example, you had your texture kind of more centered inside of your texture file, then you would also need to say the start X and Y as well. So you can say, in this case, for example, we're at 46 by 30. So you would say that the UV offset is 46, 30. Likewise, your position and your X and Y positions here, so these are already pre-calculated, but what these are set to is the width of the screen, basically, which is this dot width, minus the width of the background, and then it divides that by 2 to calculate the position that it will actually draw your texture at. Now, if for whatever reason, once again, you didn't want this to be a centered position, then you could minus or plus any kind of value from that you wanted. Now, I don't want to do that, of course, because that's super weird. So I'm going to go ahead and revert this back to the top left. But just note that is obviously something that you could go ahead and do. So that will draw our texture. Then I also want to draw the energy bar as well. So I'm just going to do a very basic energy bar here. So I'm going to say int energy bar size, and I'm going to set this to math helper dot seal, and I'm going to seal this dot handler, which is our screen handler, dot get energy percent. I'm going to times that percentage by 66. So 66 will be the height of the energy bar that I want. So that will just seal that to make sure that's correctly kind of rounded in the way that I want it to be rounded. You could obviously floor it if you wanted it to be floored, or just round it if you wanted to have that automatically determined. And then I'm just going to basically fill in an area, but you can imagine how you would be able to use draw texture here to be able to actually, maybe if you had like an energy bar here, you could then draw that using your texture. So you would just modify these offsets here using your UV and your kind of width that you want to draw, and obviously your X positions as well. So you would have another draw texture call using those specific offsets to find that energy bar inside of your texture. Now, since I'm not going to be doing that and I'm just going to be drawing a rectangle, I'm just going to say context.fill. Now, to fill, I need to provide the X and Y position. So I already know what positions I want it at. So luckily I can just type these in. So I know that I want it at the X plus 44, and then I want it at the Y plus 10. Now, the way that both fill and draw texture work is that they draw from the top left. So if we want to draw an energy bar, which we obviously want to come kind of from the bottom, then we need to be able to also negate that value. So we need to basically say plus 66, which puts us at the bottom, and then negative the energy bar size, which will put the top left basically where we want it to be, and it will only draw the size that we need it to draw. Then we can provide the width as well. So this is basically going to be the end X position rather than the actual width itself. So the end X position will be this dot X plus 144, because that's our start position. And I want this to be a width of 20. So I'm going to say plus 20. Then for the Y position, this is effectively going to be the end Y, which is going to be the bottom effectively. So we're going to say plus 10 plus 66 will be the bottom. Then finally, we need to give it a color, which is in hexadecimal ARGB. So we're going to say 0x, and then we're going to say FF for the alpha, because we want it to be fully opaque. And then we can provide the color in red, green, blue. So I already know what color I want, which is going to be D4AF 37, which is a kind of yellowish color. The final thing we're going to go ahead and do is override the render method in here. So we need to keep the super.render call, and then we need to call draw mouse over tooltip passing in the context, the mouse X and the mouse Y. And the reason we need to do that is because this method will go ahead and actually draw the tooltips for these slots. So when you hover over a slot, you want it to show what item is in that slot, so you need to call this draw mouse over tooltip. Then I'm also going to go ahead and actually show the amount of energy if you're hovering over the energy bar. So I'm quickly just going to do this. So I'm going to say int energy is going to be equal to basically this same thing. So I'm going to say energy bar size, and then I'm going to basically copy paste this from my existing code. So using the energy bar size like that. So effectively what we're saying is if it's within the bounds, and you see in here we don't actually add the X and the Y positions because it automatically calculates that. And in this circumstance, it also uses the width and the height rather than the end X and the end Y. And then all we're saying is we're drawing a tooltip using the text renderer, and then we're passing in a literal string which uses the energy over the max energy, and then I've put in FE. I'm not sure if FE is the convention for Fabric or not. I like to just think of it as Fabric energy. I'm not sure if that's the convention. If anyone knows, please do let me know, because I genuinely would like to know, but I'm not sure, so I'm just going to keep it as that. And that's fine. The final thing that we do need to go ahead and do is obviously register this screen, because it needs to know what screen it should actually be opening. And the way we do that is inside of our tutorial mod client. And at the bottom here, I'm going to say bind screen to handler, and I'm going to say handled screens register. We're going to pass in our ScreenHandlerType from our ScreenHandlerType init, and then I'm going to pass in our screen and : new. Okay, and that should be pretty much it. So we should be able to now go ahead and actually run the client, and everything should work. So let's go ahead and try that, and I will be with you when that is done. Okay, so here I am inside of the game, and I've opened my screen, and as you can see, there's actually no energy being shown inside of the GUI. And if you look in here, you can see that energy is actually still being generated, yet if I open this, there's just no energy bar in there, and that's kind of weird, right? So why is that happening? Well, the reason is, and I actually, to be honest, I completely forgot that you needed to go ahead and do this, and it's because our energy isn't synced to the client. So I briefly did talk about this in a previous tutorial, basically saying that our data isn't synced to the client. And so we do actually need to go ahead and sync our data. Now, luckily, this is super simple. I wanted this to be a separate tutorial, but I might as well just do it in this one. So let's go ahead into our block entity class, and all we need to do to make this work is override the toUpdatePacket method, and then we need to return the block entity update s2c packets, and we're going to create and pass in this. Then we need to override the toInitialChunkDataMBT method, which is the method that's called to go ahead and write the data to this packet. Now, when the packet is actually received on the client, it will call our read method. So whatever we pass into this toInitialChunkData needs to be able to be read by our readNBT method. So effectively, we're just going to call writeNBT, because that's the easiest way to do this. So I'm just going to say that varNBT will be equal to the super. Alternatively, you can just create a new compound, but the super does that for us anyway. So I'm just going to call the super. Then I'm just going to call writeNBT. I'm going to pass in the NBT and the registry lookup. And then I'm just going to return NBT. And what that will do is that will go ahead and write our energy storage, and then it will read it on the client, and that should then be synced as long as we are calling update. So instead of mark dirty here, we are actually not updating. So we need to go ahead and update the client. And the way we do that is we say if this.world, which we can't access this.world because we're actually inside of an anonymous class here. So we need to say if example energy generator block entity.world, or we can just say world to keep it simple, is not equal null, then we are going to call world.update listeners. We're going to pass in the pos, we're going to pass in the get cached state twice, so the same state, and then we're going to pass in the flags, and the flag that we want is free, but we can also just use block.notifyAll, which directly refers to that constant. So what this will do is basically when our energy storage is changed, so when on final commit is called, it will mark it as dirty and then tell it that there is a block update that needs to happen, and basically that invalidates the chunk. So the chunk will then be basically updated, and this toInitial chunk data MBT will be called for all of the block entities in that chunk, and that means that this packet will then be sent to the client, and so read MBT will be called on the client, updating our energy storage. So hopefully that should work. If we now go ahead and rerun the game, this should be fine. Now this actually still isn't working because I did a bit of a silly and I forgot to actually go ahead and basically update it when we actually manually adjust the energy amount, which we're doing here. So that's actually not going to work because we are not actually calling on final commit in this case. It will work, for example, here where we're transferring energy to the actual thing. You'll see that there is actually 0, and that is correct because there is 0 that's being transferred, but in this case there isn't 0, so it doesn't even know there is energy basically. There is actually somewhere here the energy bar, but it's not going to show up exactly how we want it to. So we do need to go ahead and also call this method inside of our tick here, so when we mark it as dirty. Now just to keep it simple, I'm going to create an update method that we can call. I'm going to create a private void update, and that basically just call mark dirty and update listeners, which I can call in here. We can call update, and then we can also just call this in on final commit as well. So if we now run again, it should work this time. So one last attempt, let's go ahead and place down our generator, and this time we can now see that the energy bar is actually being shown, and it will actually update when it reaches a obviously significant portion of what it needs to be. And as you can see, it's going to grow and grow and grow and grow and grow. And our slots are all working here in the inventory. If we try to shift click, so I'm shift clicking right now, that obviously doesn't work because we haven't implemented the quick move method, but we can do that in a future tutorial. But the tooltips are working as well, which is great. So that's all well and good, and that obviously does actually work. And if we just go ahead and save and quit, we should also be able to see that working still inside of here, which it does, which is great. So that's basically everything that we wanted to go through in this tutorial. It's actually a lot longer than I initially intended it to be because I forgot that we would have to do syncing to get that working. But yeah, that is it for this tutorial. I hope you guys found it useful. If you did, please do be sure to give it a like and subscribe if you want to know when I next upload. And if you have any problems, obviously you can join my Discord, which is linked in the description down below. And yeah, I will see you in the next tutorial. Goodbye.